slope area method. So this is a fundamental concept which is primarily used in open channel flow. So here our first step would be assuming V1 equals to V2. So by this assumption, the head loss would be equal to H1 minus H2 plus Z1 minus Z2 plus V1 square minus V2 square divided by 2G. So this would be 0, hence head loss would be equal to since we are given water surface elevation, that means we are given H1 plus Z1 minus H2 plus Z2, which will be equal to 85.23 minus 85.176, which will be equal to, let me do 0.054 meter. Since this head loss consists of two components, first is frictional head loss and second is eddy head loss. Friction head loss is like this and eddy head loss is Ke, where Ke is eddy head loss coefficient, which is given in the question. And now comes mode V1 square minus V2 square divided by 2G. Okay. Since we have assumed that V1 is equal to V2, hence this term would be equal to 0. So we are not taking eddy head loss in this, hence total head loss will be equal to frictional head loss, that will be equal to 0.054 meter. Now our step 2 will be there. Find conveyance. So you must be wondering that what is conveyance. Conveyance is nothing but Q is equal to 1 upon NA R raised to power 2 by 3 and under root HF by L. So this is conveyance, K denoted by K, conveyance. Since we have two sections, one is upstream and one is downstream, so we got K1 and K2. So our average K would be equal to under root K1 K2. So first find K1, which will be equal to 1 upon N A1 R raised to power 2 by 3. It will be equal to 1 upon the value of N is I think it's not mentioned in the question, so let me mention it. N equals to 0.022. One more thing is that is not mentioned is length. So length between upstream and downstream is 500 meters. So let me substitute 0.022 into area. Area is this 91.746 into R. R is hydraulic radius, it is 2.835 raised to power 2 by 3. So our answer would be 8353.462. Similarly, we will be calculating K2. 1 upon N A2 R2 raised to power 2 by 3. This is R1. So 1 upon 0.022. A2 area was 84.3 2.354 and R was 2.917 raised to power 2 by 3, which you can cross check. This is A2 and this is R2. So on solving this, we will get 7827.816. So the conveyance would be under root 8353.462 into 7827.816, which will be equal to 8086.37. So our discharge will be equal to K under root HF by L. So it will be equal to 8086.37 under root. Head loss was 0.054 meter and the length was 500 meters. So it comes around 84.036 meter cube per second. Now we can calculate the value of V1 and V2. So V1 will come around 84.036. A1 area was 91.746. So V1 comes out to be 0.916 meter per second. Similarly, V2 would be equal to 84.036 divided by A2, that was 84.354. So let's calculate this. So it comes around 0.996 meter per second. Now we will again repeat the step 1. We will calculate the HF. So this is kind of iteration, second iteration. Okay, step 1, find HF. So HL is composed of HF plus HE, which is equal to H1 minus H2 plus Z1 minus Z2 plus V1 square minus V2 square divided by 2G. Now this will come to first is difference of water surface elevation 85.23 minus 85.176, that came around 0.054. but now we have one more component, that is velocity head. So we'll calculate velocity head. It's coming out in negative, you need not to worry. So this will come in negative for sure. Let's see what value we get. So this comes out to be 7.796 into 10 raised to power minus 3. So the solution we get is 0.0462. Now this is HL. This will be composed of HF plus HE, where HE we can calculate. This is KE V1 square minus V2 square divided by 2G. So KE for contraction is 0.1 into, now we will use this value in mode. So 7.796 into 10 raised to power minus 3. So what answer do we get is 7.796 into 10 raised to power minus 4. Now HF would be equal to HL minus HE. So HL was 0.0462 minus 7.796 into 10 raised to power minus 4. Now let's see what we get. So we get 0.045424 meter. So now again we have to calculate the discharge K under root HF by L, where K was the conveyance. Conveyance was calculated using the area parameter, that is 1 upon N A R raised to power 2 by 3. These will not get changed with velocity. So conveyance was 8086.37. 8086.37 under root HF is this, length was 500 meters. So let's see what do we get. This comes around 77.074 meter cube per second. Now our third iteration will come, iteration 3. Okay, we will have to find velocity. 77.074 divided by area is 91.746. Similarly, we calculate V2. 77.074 divided by 84.354. So let's see the answers. 0.84 meter per second. 0.9137 meter per second. Similarly, you have to repeat the whole process until your answer gets zero down to the same value. On each iteration there is a very slight difference, but I will be stopping here since I can't do those iterations because of lack of time. So I'll mark these as my answers, though these are not the answers. You have to iterate it one more time.